Ourselves. Myself, N.SathyaNarayanan, my batchmates V.Kannabiran and P.SelvaKumar, we are going to present a project on energy conservation by reduction of standby power and protection of the apparatus. Now, the researchers around the world have focused on energy saving and improvement of lifespan of the equipment to overcome the energy scarcity. Home appliances consume 30% of all energy, that is, this amount corresponds to 12% of the carbon emission. So we need to save energy in home. Our project is mainly based on to reduce the standby power caused by the household appliances such as TV, computer, audio system, air conditioner, etc. Let us see what's standby power. Standby power is a power which is consumed by the apparatus when it is not in when it does not perform in the main function of this system. And now let us see how much percentage of energy is consumed by the standby power. 10% of energy is consumed per month by the standby power. So by reducing this, we can conserve the energy. The protection of the apparatus involves in our circuit, when the voltage fluctuation occurs, then the supply from the system is entirely interrupted.
V.Kannabiran. I am going to explain the prototype of our project. This is our project prototype, and the overall prototype is classified into 5 modules, in which the first module is a controller module. The controller module which we have used is PIC microcontroller 16F887, and which has 40 pins IC, which classified into 4 ports. The port A is used for input and port B is for output, and the pins RC6 and RC7 is for communication purpose. And this microcontroller consumes a very low power, that is 800 milliwatts, so that we can use for the reduction of standby power. And another module is power deduction module. In the power deduction modules, we are using the voltage sensor and current sensor. Voltage sensor is nothing but the rectifier circuit, which from the 230 volt AC is converted into 12 volt AC, and using rectifier circuit, the 12 volt AC is converted into 5 volt, and the current sensor unit which we have used CT1270, which is based on the Hall effect sensor. And another module is switching module. In the switching module, we are using the relay circuit. The relay circuit consists of relay driver ULN 2003 and relay, that is electromagnetic relay. And another module is this Bluetooth module. The Bluetooth modules, which is powered by 5 volt, we can power, and which is used for the communication between the user and this hardware prototype. So using this wireless module, we can communicate between any other users. And another module is nothing but the monitoring and controlling. For that, we are using MATLAB software for MATLAB GUI software to model the monitoring and controlling system. And this is the overall description about our hardware. And now the operation of the system is, whenever we are turning on the load, the working power is consumed. And this working power is indicated in the LCD monitor by usage of this voltage sensor and current sensor, because power is nothing but the multiplication of V into I. So voltage is sensed from this voltage sensor and current is sensed from the current sensor. These to produce only analog signals, but the controller will recognize only digital signals. So we are using in the PIC controller, there is an analog to digital port, which is a port A. So we are going to give the signal to the port A from the voltage sensor, current sensor, and display the corresponding voltage and current values are displayed in the LCD monitor. And whenever we are whenever the load goes to the standby mode, the current consumed by the load will be less than the working mode. The corresponding current value goes to the port A. Whenever in microcontroller, we are programmed that current values goes to the standby mode, the output port A, port B, and the relay circuit is connected, and the control signal is sent to the relay to trip the circuit to prevent the standby power loss. And this is the overall application of standby power reductions. And another application is to reduce is to protect the apparatus from voltage fluctuations. Normally voltage fluctuations occurs, the system will damages, so we have to protect circuits. And in this hardware we are using the only switch to indicating the voltage fluctuations, and whenever the switch is on, microcontroller recognizes it as a voltage fluctuation occurs and sends a control signal to relay to trip the circuit even though the load is on the working mode, so that the overall system protected from the voltage fluctuations and energy losses. Our project will be very helpful for smart home applications. Thank you.
If it is implemented, the advantage and applications are, it will provide the economic solution. It can be useful to avoid the high voltage disturbance within the short response time. Standby power consumption of equipment is eliminated, so lifespan of apparatus is increased. It will be very useful for smart homes. So our proposed system save energy more than 90% on standby mode. Thank you.